now we're going to actually talk about a multi-step problem. Say you had the prompt, how much energy must be absorbed by a 220-gram sample of ice at 0 degrees Celsius that melts and warms to 335, that should be a degree sign, Celsius. So, as always, we start with our temperature time graph. Temp, Celsius, time. So we're starting at 0 and it has to melt. So that means we're going to start at 0 and so that means we're going to start at 0. Very autofocusy today. And then it needs to take some time to melt. Then it's going to go up to 35 degrees. So now we have two parts to this. We've got a Q1 and a Q2. So let's analyze it one part at a time. So for Q1, looking at our chart, made the temperature time graph. Is the temperature changing? Nope. Absolutely it is not. It is just melting. So is it freezing or melting? Yes. We're going to use this equation, and we're going to use this C, 334 joules per gram. Q equals MC. Q is what we're looking for. We know our M is 220 grams. We know our C, we just said, was the heat of fusion. 334 degrees, joules per degrees. Gosh, joules per gram, because I know it's not going to be joules per degrees, then we'd have something in the denominator we don't need. So we've got 220 times 334. That means that first bit of energy is 73,480 joules. But we've got a second amount of energy here. Q2, go back to our chart, is the temperature changing? Well, you're darn tootin' it is. Look at it, it's going up. So now we're going to use this equation. MC delta T. We have a change in temperature, so we know we need to take it into account. Now we have the same M, 220 grams. The C is another part of this flow chart. Is it a solid? Well, at this point, it's all melted and it's going up to 35 degrees. Anything above 0 must be liquid. So no, it's a liquid. We're going to use C equals 4.18 joules over gram degree Celsius. We only use this type, the either 2.1 or 4.18, if we have a temperature change, which we do for this one. And then we need to talk about the temperature change. It starts at 35, or sorry, finishes at 35, started at 1, it's going to be 35. So our calculator, we've got 220 times 4.18 times 35. We get 32,186. Joules. This cancels. This cancels. We're left with joules. But our Q total, you must add those things together. $73,480 joules plus 32,186 joules. Our total energy is 73,480 plus 32,186 is 105,666 joules, or 105.666 kilojoules divided by 1,000. Either one of those would be a perfect answer to this problem. All right.